Welcome back for our last session of the day. I'm Duncan, your moderator, and very excited by this session. There's a very interesting topic, exciting topic there with an interesting gentleman who we're happy to welcome into our community. And so, in fact, today we'll be talking about elastic digital engineering, right-sizing digital engineering efforts. And so this is a topic that's dear to our hearts. Very interested to see the presentation from Dr. Douglas Orellana, have I got that right? And so, yes, it's, in fact, Douglas is the Vice President of Intelligent Systems Engineering in the Innovation and Capability Office, focused on developing the next generation of systems engineering solutions powered by computing and artificial intelligence. Really interesting position, interesting group we've had the pleasure of working with over the last weeks. And so previously he's held many roles of increasing authority within systems engineering organizations that span the life cycle of various systems, unmanned vehicles, special defense, radars, sonars, instruments and controls, from the concept development to verification and validation at SAIC and Northrop Grumman Corporation. Dr. Orellana has earned a doctorate in astronautical engineering from the University of Southern California, and a master's degree in systems engineering, and his bachelor's in electrical engineering from Johns Hopkins University. So quite an experience there behind you, and thank you very much for joining us as a presenter, and I'll hand over the stage to you. Thanks, Douglas.
Thank you. So I'm just the face of all this hard work that my team's doing here at Mantech. I came over to Mantech about 9 months ago, and really we've started on this digital transformation journey of Mantech system engineering. As we've been looking at providing processes and methodologies that our corporation can use across the board for various customers, we saw the need to have an elastic process. And by that, I mean a process that can scale, can adapt to the environment that our customers are needing, to the different work that we try to do, whether it's on the defense side or for federal civilian in the US, or even some of our international customers. So with that, let me begin some of this work, and definitely want to thank Matt and Heidi who have supported this work over the last couple of months. So really, throughout industry and the community, we're seeing this digital transformation of engineering itself. Not just the systems that the end users are using, but really how we look at building systems themselves. And we're really taking a look at the system of innovation. My team, and specifically, our focus or our system of interest is that system of innovation. How can we transform how we engineer, how we analyze and assess different concepts to better understand how we can meet emerging needs of our customers, and really align ourselves with the fourth industrial revolution, where if we don't leverage these digital technologies, we'll be left behind. So with that, the concepts of digital engineering, model-based system engineering, both from modeling, simulation, 3D CAD, SysML, how do we put this all into place, IoT, so we can really go end to end from a system engineering lifecycle. So a quote that I like from John Carter's Accelerate book: "The world is changing at a rate at which the basic system, structure, and culture built over the past century cannot keep up with the demands being placed on them." The reason this resonates with me so much is because today, as we are building complex systems, as we build new systems that include AI, that integrate AI augmentation, we're still using methods that were designed a long time ago, with tools for that system innovation that were designed a long time ago. We're not meeting the needs of these complex systems. We're not being able to analyze and assess, and really empower our engineering teams to move quickly and adapt to changes. So as you look at systems itself and the complexity of what's making them challenging, it's really the environment, right? We want more resilient systems. Cyber attacks across the world, are affecting, infrastructure. We want to integrate more AI and augmentation to reduce tedious tasks for humans. But then there's all these social aspects of complex systems, of being socially acceptable, having that machine-human interface and cooperation, collaboration, being scalable and sustainable. And really, as we look at developing these complex systems, we want to react and be able to answer the mail at the speed of relevance. And as you can see here, I have some pictures of air traffic control. And air traffic control is actually an interesting system to look at, and how you really need to assess what your system engineering processes are for what those emerging requirements are. With the boom of unmanned systems, whether they're personal or others used from Amazon or Google or other delivery mechanisms, to the development of commercial space operations, and now that more of these private space companies are starting to plan for the future, where space flight for commercial use is going to happen. Our air traffic across the world is going to be more congested. So how can we adapt our processes to hit those emerging needs of that air traffic system, right? And with that, Mantech has looked at adjusting our system engineering process so we can meet that in various ways. So the problem that I challenged my team earlier this year with was, how do we come up with a robust and repeatable process that can scale with different statements of work for the customers that we support? And it can't just be our traditional system engineering V that everyone loves, and it can't just be agile, because not everything has or can be put in an agile manner when it comes to complex systems. So how can we take a hybrid approach, and how can we be intentional of when we use traditional or agile practices? How can we understand how we execute those processes? And most importantly, how do we apply digital engineering across the board as our way of executing our system engineering and engineering processes? So here at Mantech, we're moving from that system engineering and reconstructed it to what we call flex engineering. And as you can see, flex engineering, it's all your typical system engineering V processes and steps, but we've taken an approach of, there's natural breaks where you can start to decide, are we going to keep with that traditional V model, or are we trying to go to agile? So we've broken it up into 4 different areas here: IDAP, ProTech, Agile Tech, and Smart, to really focus in on some of the value streams of the type of work that we do here at Mantech, and could be expanded to other organizations as well. One thing that is common across is cybersecurity, whether it's up in the front conceptual phases as you look at alternatives, or as you start to design or develop, and then obviously when you're operating and sustaining. So cybersecurity across the board is really unique, and we try to integrate those cybersecurity processes across the board as well, to be able to have secure and resilient systems. So, coming into Mantech, I kind of inherited this framework of flex engineering, but I wanted to put some meat on it. And so me and the team, we took that overarching flex engineering framework and started mapping some of the system engineering standard processes from ISO 15288, which is the system and software engineering processes, and also started to map out different digital engineering methodologies that we internally are trying to promote as the way that Mantech is approaching digital engineering. So we actually began this process of mapping, and really laying out that process architecture within a system modeling language tool. And really start to look at what are the processes that you need at every step of the way within that framework. Beyond the processes, one item that I kept hearing is flex engineering is great, but we don't know how to start. So as part of this architecting of the process at a high level, we're also starting to put in this model the methodology of how they're supposed to do their work within the modeling environment, and really kind of laying out the foundation for the style guide of how this is how we want you to model, whether they're descriptive or analytical models. And this is how you would approach that modeling, whether it's a traditional agile setting. Whether you're using a waterfall or you're breaking out your modeling efforts in various sprints and program increments, and laying down that architectural runway for the rest of the enterprise. And really, what's deemed necessary for the enterprise is really that we will always employ a digital approach. And with that, we wanted to explore how can we make it easy for our programs and our customers to look at our processes, to be able to implement those processes, and get access to the great work that we're doing here in the modeling environment that really kind of dictates and shows how we were actually delivering these models to our customers. So, like I said, we added some details to really help the cultural and organizational transformation of Mantech. Mantech as an organization, is very young when it comes to digital engineering, and we're growing really rapidly. Hiring and upskilling our workforce, but that requires guidance in how to actually apply digital engineering, across our work streams. So, part of this architecture process effort was really how can we set ourselves up so we can actually help create the system engineering management plan, but still allowing the tailoring of the processes at a high level, and then giving our programs the work instructions and any validation rules that we have to make sure that there's quality controls of the artifacts that they deliver, as well as understanding that they're using our methodologies as described from a Mantech perspective. The other thing that we did is Boeing has a very great concept of the system engineering diamond, which relates the system engineering V with kind of the digital engineering counterparts when it comes to the different baselines and architectures. So we overlaid that into our Flex framework to say these are the different baselines that we expect as we go through this process. What are the different modeling activities and modeling artifacts that we're expecting as we walk through this Flex engineering? And with all that in mind, we started a proof of concept with Stages about a month and a half ago, where we're actually taking a lot of what we did and putting into Stages, because what we needed was a mechanism that would allow us to have programs quickly select how they're going to execute their programs and get them up and running. And I did hear one of the speakers earlier about the necessary tailoring that each program needs to do, and that was kind of essential for us in allowing each program to tailor, because all the statement of works are not equal, all the tasks are not weighed the same for each of our programs. So we wanted to provide that tailoring and make it easy for tailoring for our programs. So Stages really provides a great way to communicate our framework and what goes behind that framework to all of Mantech. Although we're still in the proof of concept, my team is actually presenting this proof of concept internally in the next couple of weeks to various groups to really get buy-in from the various groups for us to really move forward into a more production and pilot environment. Beyond just presenting and communicating these processes, one of the things that my team is also looking at is making sure that as we are able to tailor and give guidance to our programs, we're also automatically allowing for us and the programs to show their customers that we are compliant or conformant to the requirements of the program based off of the processes. So we're building that into how we tailor it, and is actually going to be part of a reporting mechanism that we have as things get tailored and we're able to show the customers of that compliance. As we look at that lower level tailoring, based off of the statement of work, we're putting in enough granularity that that programs can actually say, well, I don't need this. This is not a requirement, but still have kind of that dependency. So even though they may not need it, we may guide them to say this is actually required because without this, you're not able to do X, Y, or Z. So really, this whole concept with stages, proof of concept for stages, is really for us to really grow as an organization and really provide an easier mechanism for our programs to start executing across the board. As we were looking at Flex and really trying to set up how we're going to help programs tailor, we start to look at what are the different decision points that a program would need to look at. And it really starts with, how are they going to do all traditional or all agile? If it's hybrid, where do they break out those points in executing those methodologies? What's in the statement of work? What are the different tasks that they're required to do? What tasks are they not required to do but are needed in order for them to complete an artifact or a deliverable from that statement of work? How much system engineering can a program afford that will buy down the risk to a level that enterprise can live with? Oftentimes, if you look at the literature on system engineering and how much of the effort it is, typically the better programs that are run, it's about 8 to 12%. But typically that's not the normal, and usually we get 5% of the program. So 5 to 8% of the program. So with that, there's a level of risk that the enterprise is willing to take in order for us to be more pragmatic with the budgets, the schedules. So understanding what that balance is and picking and tailoring out is crucial. And then there's the digital engineering portion of it. How much modeling are we going to do across the board? Do we have the modeling tools? Is that program ready to model? How much fidelity are they willing to put in that model? The higher fidelity, the more time, right? How much of those models are going to be integrated? So as we're building out these decision points, we're also providing different guidance points and different guides to help them answer some of these questions. We're actually embarking in developing a model governance plan guide that allows programs to really ask a set of questions to really answer some of these questions. So they're able to better assess what they need and what they don't need. And the whole goal is still to provide that system engineering rigor, but more in a more pragmatic way. So today, what we're really focused on is saying, well, we can go from full 15288, which is the full system and software process, to a smaller set, which is ISO 29110 for small entities. And that 29110 is really, here's the bare minimum that a program may need for system engineering to provide value. And really, that's what we're in the business of doing, providing value, finding a way to show our customers the minimum viable value by doing these processes. And oftentimes, as system engineers or as engineers and process geeks, we get really into the process, but the process is just there to enable us to deliver value. So for us, anything that we're doing as we're looking at these decision points is really to add value to the task and to our customers. So as we look at Flex engineering and these decision points, as you saw in the title, this is how do we add elasticity into there, right? And the tailoring allows us to make the process as big as it needs to be or as small as it needs to be, but with providing rigor. So the way we look at that is we look at the various activities in the process and the methodology. So we're able to eliminate things based off a statement of work. We're also looking at the life cycle. Are we going to do a waterfall, an incremental or spiral delivery, and how is that going to affect how we present the process and the methodologies to our programs? And in some cases, is the order right? Sometimes you have to recombine or do concurrent engineering, and that's okay. And it's just a matter of us understanding what that does to the end result. And then how deep do we have to go? Oftentimes when you look at digital engineering and modeling efforts, you take a very T-level approach. And by that, I mean, you model everything at a very high level, and you're really only digging deep into high risk areas. So in a similar manner, just because the process is there doesn't mean you have to go deep in every aspect of the technical side. So where does it make sense to go deep and where doesn't it, and for how long? And this is all really based off managing, performance, schedule, and costs, like any other program. And then the methodology, right? As much as we want to push digital engineering, we also know that some customers are not there yet. Some customers are still, using requirements in Word or databases or spreadsheets. They're not necessarily have the access to more advanced tools. But as we're looking and working with our customers, we're trying to present what is the best manner and way forward to help them achieve their goals, whether it's to get to market quicker or adjust to an emerging requirement. So our expected results from the proof of concept is really to provide Mantech a quick way for programs of varying sizes to really implement the process and efforts with a minimal lift. Oftentimes, a lot of programs in this area spend a large portion, really of time really trying to understand what is it that they have to do from a process perspective. So the ability to ask them questions through the tailoring assistant on stages is really going to help us be able to go through that process quicker, get them to a base level of methods and process that then they can further tailor for their program. So they don't have to deal with the hundreds of processes, but now they're dealing with a subset of that. The other big thing is communication across the enterprise. As a young enterprise within digital engineering, we have different pockets of excellence working with their customers. And what we're really trying to do is pull those lessons learned together and really provide a one Mantech way of doing digital engineering and system engineering across the board. So this tool is going to allow us to be able to communicate that out to the various groups, as well as giving them a way to explore, what that is, and really provide us feedback as they're working some of these things. The other thing is, obviously we're in the business of growing our enterprise. So we have a lot of solution architects that use Flex today in their proposals, but they don't know, what's behind it. So this, again, part of that communication is being able to communicate that to our customers as well. So as we kind of are starting to end our proof of concept in the next week or two, we're really looking at how do we actually finish and provide a demo internally, which is what we're working on in the next couple of weeks. And really in that tailoring process, how do we select the appropriate work instructions, style guides, and profile within our DE environment? So one of the things that we really want to do is be able to automatically, restructure our SysML model that has these work instructions, style guides, and profiles based off of the selections made in stages. So we've started to ask Method Park some of those questions on their API, so we can really look at, really providing a feature map of processes to really drive what that looks like and give our programs clean models of our work instruction, style guides, and profiles for them to use on their programs. I did sit into the big lever talk yesterday, and similar to that PLE kind of mentality, that's really the type of mentality we're trying to use here, and really set up that process feature set based off of all those decision points that we have come up with. We also want to integrate with Jira and really provide a quick way to set up for execution, as well as some of the other work item tools within our digital engineering environment. Today there's programs are being born digital, really pushing from the beginning of the program in digital engineering, as well as legacy systems trying to move into digital. So once we end this proof of concept and we make decisions to move forward, we really want to apply this mentality to a new program, which we have a couple in mind that we're just waiting to hear whether or not we want those programs to really push a pilot into that program. And most importantly, as we have these processes and methods, we want to track usage of which programs are using it, how they're using it, what's being tailored, and what's being used, because we really want to understand what isn't being used or what's not being understood. That way we can adjust that on our end, as well as get more lessons learned on how we need to adjust the guidance for those processes and methods as we move forward. So with that, I will take some questions.
Thank you, Douglas. I think a really interesting concept with flex engineering, and we see a lot of it resonates very well with what we saw, for example, yesterday from Raytheon and other similar organizations that are looking to handle the different program variants. What degree of freedom does flex engineering provide to programs? One of the questions there is really, do you plan to have kind of is there a 150% process, or then different process variants there for the different program template types?
Yeah, so that's kind of the model that we're really looking at, right? We're looking at that 150% model from a process perspective. Mm-hmm. And then what we're really starting to look at in terms of those decision points, right? All right, off the bat, how are we going to execute? Is it going to be traditional, hybrid, or completely agile? And that kind of allows us to say, all right, well, we already know if it's all traditional, then most likely they're going to use 90% of the process without tailoring. Versus a hybrid and agile, maybe an agile is more closely related to the small entities process, system engineering process. And where a hybrid, maybe you start with that full process and you start to pare it down with other questions. So that's really the way we're moving. And part of that kind of product line engineering mentality is all the guidance and the supporting documentation, or in our case, supporting models for those process also need to quickly be automated, regenerated based off of those selections. A lot of that has to do with the fact that a lot of our validation rules is really based off of here's your work instructions on how you build an architecture. We run those validation rules and we actually get status on are you doing it correctly according to Mantech. So we're really looking at a way to really kind of automate that process and not just have the process be 150% model, but also all the supporting references as well.
Great, thank you. And do keep the questions coming in. I see another one that's just come in. Does tailoring mean that the modeling could be in accordance with the standards? And are the standards always a priority?
So no, I mean, as you look at our work instructions, the actual modeling, it's so it's so lower level that, you know, there is no real standard of modeling, especially when you get the system out, right? There's a lot of stylistic items when it comes to modeling, because modeling in some sense is an art. And so, you know, I think for us, it's really, here are some rule sets or that are based off of some of our processes of things of how we want to stylistically have Mantech modeling represented, right? And then there's obviously some language or other standards that affect the modeling that have to be complied with, but they're not necessarily process related. They're more based on this is the right way of modeling based off the language standard, or whatever standard that we're using from that modeling perspective. So the beauty of being able to elasticize the methodology as well is the fact that I don't need to go and if my program has requirements and they want to represent it as use cases, I fit for that, right? Versus, you know, 100 textual requirements. So you know, my goal is really to move away from textual requirements to more behavioral type of diagrams. So we're trying to also think about that across the board of every other aspect of the process. Is it really that we have to have textual requirements, or can we have modeling requirements in some way, or be represented in different ways? So part of this process is really also understanding the artifacts that are involved, and rethinking how are these artifacts being developed, what type of artifacts can they be, because, you know, the process may say, you know, you must develop requirements, but never does it say it has to be a textual requirement, right? So, so those are the type of things that we're thinking through as well as we're looking at the tailoring pieces and providing that guidance.
Great. Well, we're certainly looking forward to working more with you and your team. I think the journey so far has been really interesting. We've had great feedback internally from Method Park, so we're very excited by the opportunity to work with Mantech. Yeah, thank you very much for taking the time to talk to us about flex engineering today, and this elastic approach. Yeah, we think there's a lot of future in that. Very, very relevant for many in the industry today. So thank you very much. Do appreciate it and sharing with the community. Yeah, that brings us to the close for the second day. We have one more day tomorrow as we move further east, and there we have, you'll find presentations from LG to Siemens to Volkswagen. They're available also as recording for those outside of the Asian time zones. So we will be finishing with a keynote from our CEO, Professor Dr. Bernd Hindel, talking about multi-enterprise environments in the new normal, new work and new processes, followed by a interactive panel. So I hope to see you in the morning, in the afternoon, or a little bit later. And yeah, thank you once again to Douglas, and we wish you a very nice morning, evening, and day. I'll see you again soon. Thank you. Bye-bye.